Hi, this is Matthew Park from the YLOC. This is the 7th grade, Lesson 28 Math Preview video. Let's get started with number 1. Christine is reselling books. She buys books for N dollars and then marks them up by 5% each. The expression N plus 0.05N represents the new price of each book. Which expression also represents this price? Well, we're given the expression N plus 0.05N. Remember that this N actually has a coefficient of 1. So we could really rewrite this expression as 1 plus 0.05N. Remembering that the blank N has a coefficient of 1 in front of them, to simplify this expression, all we need to do is combine the coefficients together or just add the two terms together. 1 plus 0.05 gets us 1.05, meaning that this simplifies down to 1.05N. This would then make our answer D. Let's move on to number 2. Which expression is equivalent to the sentence below? P is decreased by 6.5%. Well, if we're decreasing by 6.5%, what we'll be doing is subtracting 6.5% from 100% of P. Essentially, whenever you have one variable like P, or say X, and we're decreasing it by a certain amount, we will always start with 100%. So if we're subtracting 100% of P by 6.5%, we can rewrite this as 100 minus 6.5. Remember your decimal places. And if we go ahead and do this, we'll end up getting 93.5% P. This would then make our answer B. Let's move on to number 3. The dimensions of Martha's new furniture piece are W and H. The expression 2 times W plus H represents the perimeter of the furniture. Which expression also represents this perimeter? We have 2 times W plus H. To simplify this expression, what we can do is multiply in the coefficient to both W and H. In other words, we can do 2 times W plus 2 times H. This gets us 2W plus 2H, which makes our answer D. You can try the rest on your own. And let's go ahead and look at number 7. Petros drives a car at a speed of S miles per hour. He increased his speed by 30% in the last 10 minutes. The expression 1.3s represents his increased speed. Which expression also represents the current speed? Well, we have 1.3s. And we want to find an equivalent expression that also means the same thing. Let's go ahead and look at our answer choices. If we looked at A, we have S plus 30s. Well, this really simplifies. Remember that there is always a blank coefficient of 1 in any standalone variable. So if we have like an x, we'll always have a coefficient of 1. Knowing this, we can easily rewrite this expression as 31s. 31s does not equal 1.3s, so we know for a fact that A cannot be the answer. Say we looked at B. We have S plus 3s. Well, we know that just goes down to 4s, which is still not 1.3. So let's keep moving on. Knowing that, we know that B can't be the answer. And say we looked at C, S plus 0.3s. Remember that there's a coefficient of 1, so we can simplify this expression to 1.3s, which is the same thing. So our answer, therefore, BC. Let's go ahead and look at these. Write the number in standard form. Essentially, what standard form means is just rewrite this expression without any multiplication. So we have 2.6 times 10 to the third. So an easy way we can solve these kinds of problems is to look at it in a different way. Say for the first one, we have 2.6 times 10, 3. Whenever you have a multiplication symbol and you're multiplying by 10 to some power, this could be 10 to the 5 or 10 to the 999. As long as it's 10 to some exponent, we can use this technique. So all we need to do to simplify this expression into standard form is to move the decimal places, or this decimal point, to the right as how many places are in the exponent. In this case, it's 3. So we need to move this decimal place 3 points to the right. So we go 1, and then we can add in another 0, 2, and then add in one more 0, 3. So we're left with 2,600, making our answer 2,600. Say we looked at number 3. We have 1.11 times 10 to the 2. All we do is move our decimal places to the right 2 times. So what we'll do is 1, 2. We get 111 decimal point. Or in other words, we just have 111. Hopefully you're starting to get the picture now. We can try a harder one like number 6. We have 1.544 times 10 to the 10th power. In this case, we're going to move our decimal places 10 times to the right. So 1, 2, 3, add in a 0 whenever you run out of numbers, 4, 5, 6, 7, 8, 9, 10. So we end up getting a pretty big number, which is whatever that number is. I hope this was helpful, and thank you.